Hello everyone, welcome back. In this video I want to cover two more problems relating to properties of triangle, and so let's start with the first one. I'll just read it out once. If S is equal to a square minus b minus c whole squared, then tangent of a upon 2 is equal to. So basically we want to figure out the value of tan of a by 2, and we are given with this equation. Also note that S denotes the area of a triangle. This is basically notation. So let's think about how we are going to start. Again, going by our toolkit concept or toolkit abstraction that we pretty much cover in every video. If you just consider the right hand side, and again, why did I just choose the right hand side and not the left hand side to start with? Well, because if you just consider the right hand side, we observe that this is strikingly similar to what we know from the cosine rule that we have in our toolkit, because let's expand this. It's very obvious. If we just expand, and this is the right hand side, if I expand this, I'll get a square minus b square plus c square minus 2bc, right? And since we have a negative sign in front, if you just open the bracket, it's going to be equal to a square minus b square minus c square plus 2bc. Now these first three terms are very interesting because they are exactly what corresponds to the cosine rule for a square, the side a. So if I just write down the cosine rule for the side a, it's going to be equal to a square is equal to b square plus c square minus 2bc cosine of the angle between b and c, which is a. Now let's move these two guys to the left hand side. If I do that, I'll get a square minus b square minus c square is equal to minus 2bc cosine of a. Now compare these three terms with these three terms. In fact, they are equal. So what that basically means is that instead of this, I can write minus 2bc cosine of a. So let's do that, and immediately we are observing that we will get bc as common. So if I do that, I'll get minus 2bc cosine of a plus 2bc. So now we can take bc as common, but that's just that's just implied because we cannot simplify this any further. So let's see what we can do with the left hand side, because ultimately we would like to prove that the left hand side is equal to the right hand side. That's what the problem is asking. So if you just consider the left hand side, this is the problem. Again, if you just visit your toolkit, in the previous videos I mentioned about a result in which, or a pattern I guess, or a rule in which we relate the sine of one of the angles with the area of a triangle. So let's go back. I don't think it's sorry sorry, I don't think it's in my toolkit right now. I just have one entry. Let me just check. I just created one entry in my toolkit, and it's just a simple notepad file. Okay, so this is different. This is from the last video. Anyway, I know that rule, but if you are maintaining a physical copy of your toolkit in form of diary, or maybe hardware copy, I mean software copy in form of a notepad file, you must have added this entry. which basically relates to the area of a triangle and sine of one of the angles. So let's do that real quick. So basically it says consider a general triangle. So this is a general triangle, this is A, let's say this is B, this is C, this is the general triangle, and let's also label the sides. Let's drop a perpendicular. Now we will get two sub triangles, right? Let's consider the left one, and I will just apply the trigonometric ratio sine of A. So sine of A is equal to opposite side upon hypotenuse. Opposite side is just height and hypotenuse is C. Now we want to relate the area of a triangle with the sine of the angle, any angle. So we know that S, or maybe we can denote this by triangle, which is the area, is equal to half into base into height, right? Now let's solve for H. So basically, H is equal to 2S upon B. Now let's just plug this value into this equation, and if I do that, I will get sine of A is equal to 2S upon BC. So let me ask you a question here. Was that too hard? You didn't like memorize any formula, you just derived it in about 30 seconds, and I don't think that should be hard, and that's the way you should deal with most of the problems and patterns, and that's the beauty of our toolkit concept. Anyway, let's proceed. So we got the value of sine of A. Now let's since we only have S in our left hand side of our original equation, let's solve for S. S is equal to BC sine A upon 2, right? I just solved for S. Now let's plug this value into this equation. Basically I mean, it's not an equation right now because that's what we would like. No, it's actually an equation, sorry about that. Basically this is an equation, and we have to calculate the value of tan of A by 2. I'm sorry about that. So let's this is the left hand side, so this is equal to I need to scroll above one more time. This is equal to minus BC cosine of A plus 2 BC. Okay, minus BC cosine of A plus 2 BC. Alright, now immediately we can cancel the BC's, and so let's see what we got here. We got, okay, so I think we are almost there, so let's just simplify this. Let's see if we can simplify this, and now everything is in terms of A, which is the whole angles, but we want the final answer, or what we would like to solve for, tan of A by 2 is a half angle. So basically it makes sense to convert from complete angle to half angle, so we will just apply the basic formula, basic transformations. Sine of 2A is equal to 2 sine of A by 2. I mean, sine of A is equal to 2 sine of A by 2 cosine of A by 2, and we also have this 1 by 2 term, and let's see. So I think there should be 2 here. One second. Minus yeah, so I missed out leading 2 in this term, so there should be a there should be a 2 sorry, there should be a 2 here. Now let's take the 2 common. We are left with 1 minus cosine of A. Now this is equal to something. Let's see what this is equal to. 1 minus cosine of A. So cosine of a is equal to 2 cos square a minus 1, right? um, so let's switch both sides. So if I do that, I'll get 1 minus 2 cos square a is equal to minus cos, actually this will be a by 2, is equal to minus cos a, right? Now we just need to add 1 on both sides so that this becomes equal to this. So if I add 1 on both sides, let's see what we will get. This will become 2 minus 2 cos square a by 2, and this is obviously 1 minus cos a, and I think we can further simplify the left hand side. So if I just take 2 common, we get 1 minus cos square a by 2, and I'm sure this is the most fundamental property of trigonometry, that sine square of any angle plus cos square of the same angle is equal to 1. So 1 minus cos square a by 2 is equal to sine square a by 2. So basically 1 minus cosine of a is equal to 2 sine square a by 2. So in this equation, instead of 1 minus cos a, I can write 2 sine square a by 2. So let me do that. 2 sine square a by 2. Now let's cancel sine a by 2 term, so the exponent will become 1. Let's cancel this 2, and so now let me just separate a line here. We need to calculate tan of a by 2, right? So if I just divide both sides of this equation by cosine of a by 2, tangent of a by 2 is equal to 1 by 4, and that's the final answer. So there you go. Basically I was kind of explaining you this, so it took actually a little bit more time, but if you just do it yourself on a piece of paper using the basic principles that we know, it's not going to take that much. And again, the basic rule is that you gotta trust you gotta trust your toolkit, because your toolkit is basically the collection of patterns that you discovered yourself, and we keep mentioning that and referring to that in pretty much every video. And so in this problem also we started, so let me just go to the original problem. In this problem also we started with our toolkit concept. We had the cosine rule in our toolkit, and the right hand side looked very similar to the form of the cosine rule. So we started with the cosine rule and we reached an intermediate step, and then we started with the left hand side. We could also start with the we could also have started with the left hand side, since we also had a formula in our toolkit, or maybe a pattern in our toolkit, which relates to the area of a triangle and sine of an angle. So if we started with the left hand side, we would have again reached a intermediate step, and then we would need to solve for the simplify the right hand side. And after both the sides are simplified, basically we just cancel stuff and just simplify again further and reach out the final answer. So let's look at another problem. I'm going to create a new page here, I think. Let's do white over black. So white, how about this? How about I use my favorite color, orange, just for change. Okay, so let me write down the problem. So if b plus c is equal to 3a, so b plus c equals 3a, then basically we have to prove that cotangent of b by 2 times cotangent of c by 2 is equal to 2. So this is what we would like to prove. So let's think about how we are going to solve this. So basically, if you just look at this question or problem, you would immediately realize, if you just refer to your toolkit, in fact we solved a similar problem in the last video. You would realize that we already have one pattern for this problem or this kind of problem, so we can just use that. And basically I think I have that pattern in my toolkit. So this is my toolkit. So I'm not sure if you can see, but it basically says that if I want to relate sides of a triangle, basically it says that if I am given with sides of a triangle in a problem, and I want to either relate it to the tangent of some half angle or cotangent of half angle, or I am asked to find the tangent of half angle or cotangent of half angle, then I can just apply the law of sines, and then after that I can apply the trigonometric transformations to achieve the result. And it's pretty simple. It's nothing very, it's not very technical or very mathematical. It's a very informal rule, and in fact you should always write patterns very informally, because after all it's your toolkit, you are going to be using it, right? So let's apply this pattern from my toolkit. Okay, so let's first apply the law of sines. So sine of b, and I'm also not writing the constant because it's going to get cancelled. So sine of b plus sine of c is equal to 3 sine of a, right? Okay, so sine of let's convert everything from the whole angle to the half angle, because in the final answer we are dealing with the half angle. So it's going to be 2 sine of b by 2 cosine of b by 2 plus 2 sine of c by 2 cosine of c by 2, let me just scroll down a little bit, is equal to 3 sine of a by 2 cosine of a by 2. Okay, so now we converted from the whole angle to the half angle. Let's simplify now. So let's just do hit and trial, and like we have done in the previous problems, we are somehow going to make this make these two terms convert these two terms into a single term, and then we are going to cancel stuff from both sides and finally get the answer in the simplified form. So let's see what we can do. So if you just observe this form, it looks very familiar to something like sine of let's try sine of b plus c by 2. So sine of b plus c by 2 is equal to sine b by 2 cosine of c by 2 plus cosine of b by 2 times sine of c by 2, right? Now let's pattern match this and this. So we got the first term sine of b by 2, we also got the first term here sine of c by 2. We also have the leading coefficient 2 here. So if I just multiply 2 with both sides of this equation, it's not going to affect the equation, right? So I can do that. So now we also have taken 2 into account, but we are missing this second factor, and both of the second factors are cosine terms. So if I multiply this equation by cosine of b minus c by 2, let's see what's going to happen. And again, this is just hit and trial. You can try with b plus cosine of b plus c by 2. If I do that, I'm going to get cosine of b by 2 cosine of c by 2 plus sine of b by 2 sine of c by 2. Now let's imagine we multiply these two equations, and let's see if we get our basic requirement fulfilled, which is the left hand side of this equation. So if I multiply this term by this, I'll get 2 sine of b by 2 cosine of b by 2. So I got this term, but I also got cos square c by 2. Anyway, let's just ignore that for now. Now to get this term, if I multiply these two, let's see what we'll get. I'll get 2 sine of c by 2 cosine of c by 2. So we got this, but we also got 2 cos square b by 2 extra. So let's just ignore that because we got the term anyway. And also we will get 2 more terms, because if you multiply these two guys with this term, you're going to get something extra. Anyway, let's just multiply this. So if I multiply this by this, I'm going to get 4 terms. Let me write down the 4 terms. 2 sine b by 2 cosine of b by 2 cos square c by 2. And you have seen me done this before. Basically this thing is equal to sine of b, right? So plus the second term is going to be 2 sine of c by 2 cosine of c by 2 cos square b by 2 plus the third term is going to be let's see, is this negative 2? Let me just check. No, it's 2. Okay, 2 sine c by 2 cosine of c by 2 sine square b by 2, and the final term is going to be 2 sine b by 2 cosine of b by 2 and then sine square c by 2. Oops. Alright, so basically this thing is sine of c, this thing is sine of b, this thing is sine of c. Let's take the common parts. So sine of b, if I just take sine of b common, I'm going to get cos square c by 2 plus sine square c by 2, which is just 1. Similarly, if I take sine of c common, which is this and this, I'm going to get sine square b by 2 plus cos square b by 2, which is again 1. So we got sine of b plus sine of c. So if I just scroll above, I will see that sine of b plus sine of c was indeed our left hand side. So basically what that means is that I can write the left hand side, which is this, as the product of these two guys. So let me just do that. So if I do that, if I do that, 2 sine of b plus c by 2 cosine of b minus c by 2, and now let's focus on the right hand side. This was our right hand side. 3 sine of a by 2 cosine of a by 2. Now recall that we can basically there's a fundamental property that that in a triangle the sum of the angles is equal to 180 degrees. So basically what we like to do is convert from this a to b and c, and we can always do that. So if I do that, basically I will get 3 cosine of b plus c by 2 times sine of b plus c by 2, and you have seen me done this in the previous videos, quite obvious. Okay, so oops. Okay, so 3, actually it's going to be 6, I think. Yeah, because I think I missed a 2 here. Yes, actually we had a 3 here, 3 sine of a, but since I converted from the whole angle to the half angle, it should be multiplied by 2, and 2 times 3 is 6, so it should be 6, right? So oops, 6 sine of, I always over scroll when I'm scrolling above or down. Anyway, 2 sine of b plus c by 2 cosine of b plus c by 2. Let's see if anything is cancelling. Oops, yeah, sine of b plus c by 2 is present on both sides and cancel. Now let's just expand this, and I think we are pretty much done. So if I just expand both sides, I'll get cosine of b by 2 cosine of c by 2 plus sine of b by 2 sine of c by 2, and don't forget this 2, so this will also be 2, is equal to, actually let's simplify, let's divide both sides by 2, so this will become 3. If I do that, I can just ignore this coefficient, right? And this will become, this right hand side will become 3 cosine of b by 2 cosine of c by 2 minus 3 sine of b by 2 sine of c by 2. Now we are asked to calculate the cotangent of b by 2 times cotangent of c by 2, right? So let's see what we can do here. Let's bring this term to this side, and let's bring this term to that side. If I do that, I'll get oops, cosine of b by 2 cosine of c by 2 is equal to this is going to be 2, right? 4 sine b by 2 sine c by 2. Now let's divide both sides by sine b by 2 sine c by 2. If I do that, I'll get cotangent of b by 2 times cotangent of c by 2 is equal to 2. And let me just verify 1 second if this is the correct answer. Yes, it is indeed the correct answer, and congratulations, you solved both of the problems, and you saw that how similar they were to the problems that we have already solved, and we didn't use any like memorized formula or something. Basically we just made use of our patterns and some basic fundamental formulae to arrive at the solution. And I think if you just practice enough, you are going to see that it's very efficient. And if you just like memorize pretty much all the formulas, you will start seeing that it's a lot of pain, and you need revisions, and you will not be able to like store all those formulas, all those lengthy formulae into your head always. But as far as the patterns are concerned in your toolkit, you will always remember them because they are simple, they are informal, and they are present in your toolkit that you designed. Okay, anyway, I'll see you in the next video. Thanks for watching. Bye.